Hi everyone, welcome to Unacademy, India's largest learning platform. So before I start my class, let me tell you a bit about myself. My name is Aishwarya Agarwal and I'm a quantitative aptitude trainer and I'm teaching students since last 4 years. And during this tenure of 4 years, I've trained more than 1000 students for various management entrances like CAT, GRE and GMAT. Prior to that, I have done my master's in mathematics from University of Delhi. And before that, I have done my graduation from Miranda House, University of Delhi in mathematics only. Alright, so this was all about me. So you guys might be thinking, how can you attend Unacademy lessons? How can you subscribe to Unacademy? So let me just clarify all these doubts for you. So the steps are very simple. You just have to go to Google Play Store, type Unacademy there, and you have to install the Unacademy Learning app from there. As soon as you install the Unacademy Learning app, then you have to select the category for which you want to do the preparation. Okay, so since you want to do the preparation for CAT, select CAT as your category from there. As soon as you select CAT as the category, you have to click on Get Subscription. Okay, as soon as you click on Get Subscription, you will see two plans. Okay, one is the Plus subscription, other one is the Iconic subscription. Okay, so let me just explain you the difference between the Plus and Iconic subscription. So there are a lot of benefits that you get from the Plus subscription. First is that you will have access to the classes from India's best educators. All the classes would be live and very well interactive classes would be there. You can even ask your doubts in the classes. After each and every class, you will get notes of the lecture, and along with that, you will have access to live tests and quizzes which are made by the top faculties of India. Okay. Along with the Plus subscription, there is one more kind of subscription, which is the Iconic subscription. All the benefits of Plus would be there in the Iconic subscription. Along with that, you will get personalized attention from your educator. Okay, you will get the regular test analysis and other management exams preparation will also be included. Alright, okay. So I'll be telling you about the price of both the Plus and Iconic subscriptions. Yes, hi Arjit. Welcome to the class. Okay, so let us discuss the pricing of Plus and Iconic subscription. The price of 12 months subscription is 17,500 and the price of 24 month subscription is 21,000. Okay, you can use my code AAISH10 to get the instant 10% discount over the entire fee. Okay, the price of Iconic subscription is that for 12 months it is 30,000 and for 24 month subscription it is 41,000. Okay, here also you can apply my code AAISH10 and get the instant 10% discount over these fees. As soon as you'll apply my code, you will get the discount and the fees of 12 months would be 27,000 and the fees of 24 months would be 36,900. You'll have to apply the code here. Okay. So these are the students who have scored very well in CAT 2020. These are our 99 plus percentilers. Okay. So you guys can also be among these people. Okay. If you start the preparation of CAT from right now only. Okay. So if you are preparing for CAT 2021 batch, go for the Unacademy subscription as soon as possible. The sooner the better. Okay. So that next year you will be in this list. Now, let me give you some information about the batches that are going to start. So today a batch was started. It is a weekend batch, okay? And from 8th of March, we are going to start an exclusive weekday evening batch and also a perfect score 2.0 batch. All right. So these are the two batches which are starting. So please go ahead, join the subscription so that you don't miss even a single class from this. All right. Now, so a very good opportunity is there for you guys. There is a weekly scholarship test that is held. Okay. So please participate in this test, give this test, and if you score well in this test, you'll be eligible for scholarships up to 55 lakhs plus. Okay. So this is a wonderful opportunity for you guys. Go ahead with this test, attempt this test so that you can get the scholarships. Okay. Now, so let us start with our class. Okay, so in this class, we'll be discussing about classification of real numbers. Okay, so this topic is very important for all the students who are preparing for CAT, especially for quantitative aptitude. Okay, so this is the first topic of the quant. In order to understand the questions of quant, this topic is very important for the students who are not from engineering background and not from science background, or the students who have studied maths till 10th standard or 8th standard. They should definitely watch this class. All the basics of your number theory would be cleared in this class. Okay, and if you'll attend this class, the questions related to you will be find less difficulty, or even the questions related to number theory would seem easy for you. Okay, so let's start. Okay, all right. So first of all, let us understand how are the numbers classified. Okay, so numbers are classified into two categories. One are the real numbers. Second category is the imaginary numbers. Okay, so what are the real numbers? The numbers that we are using in our daily life: 2, 3, 500, 1000, 50,000. Okay, these come under the category of real numbers. Okay, I'll be explaining about real numbers in detail as well. Other category are imaginary numbers. So suppose if I give you an equation to solve. Let us solve this equation together. X square plus 2 is equal to 0. Let us try to solve this equation together. Okay, so it will be x square is equals to minus 2. X would be equals to under root of minus 2. Now, have you seen any such type of number? Can you represent this number on our real line, on the number line? No. Okay, so such type of numbers, when inside the root we get a negative number, we get this negative sign inside the root, such type of numbers come under the category of imaginary numbers. Okay, so these numbers are known as imaginary numbers. All the numbers which are not imaginary numbers come under the category of real numbers, and we'll be discussing about real numbers in detail. All right, okay, so real numbers can be divided into two categories, which is the first category is rationals. The second category is irrational numbers. Okay, so this is very important. Let us understand what is the meaning of rational number. When I say that x is a rational number, what do I mean? Okay, so a number which can be expressed in the form of p by q, where p and q are integers and q is not equal to 0, is called a rational number. Okay, so your number can be any number which can be represented in the form of p and q, where p and q both are integers and q is not equal to 0. Okay, why is q not equal to 0? Because if you put q as 0, then division by 0 is not possible. Okay, so any number which can be expressed in the form of p by q and q is not equals to 0 is a rational number. For example, 2 by 3. Okay, 6 by 7. 1000 by 7987, any number. Okay, so all these numbers can be expressed in the form of p by q, where q is not equals to 0 are rationals. Okay, I hope this definition is clear to you. Now let's understand what are irrational numbers. Okay, so irrational numbers are the numbers which are not rational numbers. It is the opposite. All the numbers in the real line, if you remove rational numbers from it, the numbers that will remain are irrational numbers. Okay, so let us understand the definition. The definition of irrational number is that any non-terminating and non-recurring decimal is an irrational number. Now, there are two difficult terms here. What is non-terminating? What is non-recurring? So let us understand these terms. What is the meaning of the term terminate? What is the meaning of this term terminate? Terminate means to end. Okay, so what would be a terminating decimal? Yes, terminating decimal is a decimal which has a fixed number of digits after the decimal. Decimal के बाद जो digits है वो खत्म हो जाते हैं. Okay, for example 5.789. There are 3 digits after the decimal, so it is a terminating decimal. खत्म हो रहा है. Now what is a non-terminating decimal? Okay, suppose there is a decimal like 1.333 and so on. The numbers after the decimal point are not terminating. There are not fixed number of numbers after the decimal point. So this is a non-terminating decimal. And such type of numbers are come under the category of terminating decimal. non-terminating decimals. Okay. Now let us understand what do we mean by non-recurring decimals. Recurring means something which occurs again and again, right? So any decimal which is repeating is known as a recurring decimal. The digits after the decimal points are repeating is known as a recurring decimals. So non-recurring decimal means the decimal in which the digits after the decimal are not repeating. Okay, so in this decimal 1.333, the digit after the decimal is repeating. Okay, so this comes under the category of recurring decimals, hence it is a rational number. Okay, but if I write a number like this, 5.7891027532, do you see any pattern here? Are the digits repeating? No. So such type of numbers come under the category of non-recurring decimals. Okay, so the definition of irrational number is that any non-terminating non-recurring decimal is known as a irrational number. Okay, and terminating and recurring decimals come under the category of rational numbers. Okay, so I hope the definition of rational and irrational is clear. If it is clear, can you please type an OK or thumbs up in the chat box? Okay, all right. So let us discuss a few more definitions. So now we are clear with the definition of rational numbers and irrational numbers. Okay, so further, these numbers are also divided into subcategories. So let us understand what are natural numbers. Okay, so natural numbers are our counting numbers. Natural numbers are counting numbers. So whenever we count any numbers, we start from 1, 2, 3, 4, 5, 6 and so on. So natural numbers are these counting numbers. So the counting numbers starting from 1, 2 and 3 and so on are known as natural numbers. Now what are whole numbers? If I add 0 to the list of natural numbers, they will become whole numbers. So whole numbers are the numbers, the counting numbers if I start from 0. So 0, 1, 2, 3, 4 and so on. These are the list of whole numbers. Okay, now on our number line, if this is my number line, okay, this is the position of 0. On the right hand side there are certain numbers, 1, 2, 3 and so on. On the left hand side also there are some numbers, and these numbers are known as negative numbers, -1, -2, -3 and so on. Okay, so the entire number line, on this entire number line, the numbers are divided into 3 categories. One are positive numbers, second category are negative numbers, and third category is 0. Okay, so all these numbers 0, 1, 2, 3 along with negative numbers -1, -2 and -3 come under the category of integers. Okay, so for example, -5 is an integer, -7, 7, 55, 0, all these numbers come under the category of integers. Okay, I hope I'm clear with the definition of integers. Now let's see what are prime numbers. Okay, so if you divide any number by some other number, okay, let us take a number 4. If I divide 4 by 2, we'll get 2. The question would be 2. Okay, it means 4 is divisible by 2. Okay, so now let us understand what are prime numbers. Prime numbers are those numbers which are not divisible by any other number except 1 and the number itself. Okay, 1 तो सारे numbers को divide कर देता है, right? We can divide each and every number by 1. Okay, so 1 is not counted here. So prime numbers are those numbers who have only 2 factors. The factors are 1 and the number itself. Okay, 1 and itself. Okay, so all those numbers who just have 2 factors, 1 and the number itself, are known as prime numbers. These numbers cannot be divided by any other number. Alright, okay. Now let us understand what are composite numbers. Composite numbers are the numbers which are divisible by more than two factors. Okay, composite numbers are the numbers who have more than two factors, that is one and the number itself. This is other factors. For example, let us take example of 12. So let us list down the factors of 12. The factors of 12 are 1, 2, 3, 4, 6, 12 itself. Okay, so these are all the factors of 12. It means 12 is a composite number. Okay, all right. So the numbers which have more than two factors, that is number and itself, one and itself, then those numbers are known as composite numbers. I hope I'm clear with the definition of composite numbers. All right. Now let us understand what are even and odd numbers. Okay. Even numbers are the numbers which are divisible by 2. Odd numbers are the numbers which are not divisible by 2. For example, the list of even numbers is, let us list down some even numbers. 2, 4, 6, 8. 0 is also an even number. -2, -4. Alright. So all these numbers which are divisible by 2 are known as even numbers. And numbers which are not divisible by 2. For example, 1, 3, 5, -1, -3, -77. So all these type of numbers are known as odd numbers. Okay, so I hope these definitions are clear to you. See, these definitions would be very helpful when you solve the questions. When you read the questions, to understand the question, these definitions would be very helpful. Yes, welcome to the class, Isha. Yes, Isha, ये CAT की first class है. We are starting with number systems. We have just discussed the definitions and the classification of numbers. Okay, let us move ahead. Okay, so now we all know what are the basic arithmetic operations. What are the basic arithmetic operations? We have plus, which adds two numbers, minus, which subtracts two numbers, division, multiplication, and etc. etc. So these are the basic arithmetic operations that we have. Okay, now there is a certain order in which we have to operate. There is a certain order in which we have to solve any equation or any problem which is given to us. If a question has multiple operators, then which operator should we solve first? Which operator should we solve at the end or afterwards? Okay, so there is a rule for that. Okay, so there is a certain order that needs to be followed, and that order we are going to discuss right now. Okay, so this order you can remember by remembering the term BODMAS. Okay, now let us understand what this term means. Okay, so B in BODMAS stands for brackets. Okay, so brackets are also of 4 types. Let's see. So first type of brackets is this box bracket. Second type of bracket are these curly brackets. Third type of bracket are these brackets known as parenthesis. And then we have this bar bracket, also known as vinculum, but or you can say just the bar bracket. Okay, so this is the order in which they will be solved. First, we will be solving this bar bracket. Then we solve this parenthesis. Then we solve this curly bracket, and then we solve this box bracket or square bracket. Okay, so first of all, we solve the operators which are under the brackets, which are inside the brackets. Okay, now second in the order is off. Off stands for multiplication. If off term is there, then we replace it by multiplication, and this is solved after the brackets. Okay, now after this we do the division. If division operator is there, we do division. Okay, then we have multiplication, then we have addition, and then we have subtraction. So this is the order that we need to follow while solving such type of questions. I hope this is clear. Okay, so now let us solve a question using this rule, this order of arithmetic operation, which is BODMAS. So let us try to solve this question together. Okay, so this question is given to us. So as I said, we will be solving the brackets first. Okay, so let us solve the inside bracket first. So I'll be solving this question step by step. Please follow. 3 plus 1 upon 9 of, now this is the curly bracket, so I'll be solving it afterwards. First of all, we'll solve whatever is in the parenthesis. Now in the parenthesis also we have two operations here, plus and minus. Now let us go to the rule of BODMAS. Which operation should we do first, addition or subtraction? So we'll be doing addition first. Let us add these numbers. What is 19 plus 8? It is 27 minus 6 plus 1 by 2 of 54 plus 3. Okay, so this was our first step. Let us do the next step, which is 3 plus 1 upon 9 of 30 minus, now 27 minus 6 is 21, so I'll replace it with 21 plus 1 by 2 of 54. Now I can solve this off also. So off stands for multiplication. So we will do 1 by 2 into 54, which is equal to 27. So I'll replace it with this. Now we'll solve whatever is inside this curly bracket. So this will be 3 plus 1 upon 9 of. Let us solve this bracket, what we get from here. Again, here are two operations, plus and minus. So we will add the numbers first. So I get 57 minus 21 plus 3. Further, this would be 3 plus 1 upon 9 of. Now, if you solve this subtraction inside this curly bracket, we get 36 plus 3. Okay, so now we'll operate this operator, which is off. So I get 3 plus 4 plus 3. 1 by 9 of 36 is 4, which if I simplify is equal to 10. Okay, so this is the order in which we can simplify the equation using the order BODMAS. Alright, I hope this is clear. Next. Okay, so now let us discuss again about recurring decimals. We already know what are recurring decimals, the decimals in which the digits after the decimals are repeated. Decimals in which digits or set of digits are repeated continuously. What do we mean by this statement? Let's see. So if I have a decimal of this form, 6.333 and so on, it means the digit 3 is being repeated. So this decimal can be represented in this form, 6.3 bar. Okay, so what does this bar represent? Bar on any number after the decimal represents that particular digit is being repeated continuously. Okay, for infinite number of times, this digit is being repeated. Okay, now what do I mean by set of digits? Suppose the number is 6.798, 798, 798. Okay, so it is also getting repeated continuously, infinitely. Okay, so these three digits are getting repeated in this pattern. So this number can be represented as 6.798 and a bar would be on it. Okay, so this bar on these three digits represents the number 6.798, 798, 798 and so on. Okay, understood? Alright, so now how will we represent these numbers into fractions? How can we change, how can we convert the recurring decimals in the form of fractions? जो decimals recurring नहीं होते हैं, for example we have 2.5. How do we convert them into decimals? How do we convert them into fractions? We remove the decimal and decimal के बाद जितने digits होते हैं, we write that as a power of 10. Okay, we use this notation. For a number like 6.75, we remove the decimal and we divide it by 100. Okay, so we have this trick. We have this method of changing a decimal into a fraction. But can we do this when we have a recurring decimal? Okay, the number of digits are infinite. Then how many zeros will be put in the denominator? Right? So there is no such thing. So there is a trick by which you can change the recurring decimals into fraction. So we'll be discussing about this trick in detail. Okay, so let us solve this question. Okay, so before we learn the trick, let us understand what is the logic behind that trick. How do we know that that trick will work? Let's see. So we have this number 0.55555, and we have to convert this recurring decimal into a fraction. Then what do I do? Okay, so what I'll do is that I will assume this number. Let us write x as, see, this number can be written as 0.5 bar, as 5 is getting repeated. Okay, so let us take this number as, let x is equals to 0.5 bar. Okay, so see, the number of digits that are being repeated is just 1. 5 is getting repeated every time. So I multiply the entire equation, this equation 1, by 10. If I multiply this equation by 10, what do I get? I will get 10x is equals to 5.5 bar. Okay, let us take this equation as, let us mark this equation as 2, equation 2. Now what do I do is, I subtract both these equations. Let us subtract these two equations, equation 2 minus equation 1. What will I get? I will get 9x is equals to 5. From here, I can write x is equals to 5 by 9. Now see, earlier the x was in the decimal form. Now the x is in fractional form. So we have successfully converted the decimal into the fraction. So 0.5 bar can be represented as 5 by 9, can be written as 5 upon 9. Okay, let's do it with other decimal. So the number is 0.818181. So this can be written as 0.81 bar. Okay, so let us let us assume x is equals to 0.81 bar. Alright, now the number of digits which are getting repeated in this decimal are 2. 8 and 1, 81. This is getting repeated again and again. So I will multiply this by 10 square. Okay, here only one digit was getting repeated. So I multiply it by 10 raised to the power 1, that is 10. Here it is getting repeated by 2 digits. So I will multiply it by 100, 10 square. Let's do that. Let us make this equation as equation 1. Let us write this. So this would be 100x is equal to 81.81 bar. Let us mark this as equation 2. Okay. Now I'll subtract equation 2 minus equation 1. Then what do I get? I get 100x minus x is equals to 81. So this will be 99x is equals to 81. So from here I can write that x is equals to 81 upon 99. Okay, so earlier one digit was getting repeated, so we got 5 by 9. Now two digits are getting repeated, so I got 81 by 99. Let's do it with one more decimal. Okay, so we have this decimal. So here 3 digits are getting repeated, 2, 2 and 5. So can I write this decimal as 0.225 bar? Okay, so let us do the calculation. Let us write, let x is equals to 0.225 bar. Let us take this as equation 1. Now the number of digits that are getting repeated are 3. So I multiply the equation by 10 raised to the power 3, which is 1000. If I multiply this equation by 1000, I will get 1000x is equals to 225.225 bar. Alright, let us mark this as equation 2. Again, I'll be subtracting the equations. Let us do equation 2 minus equation 1. What do I get? 1000x minus x is equals to 225. Now this would be equal to 999x is equals to 225. So from here I will get that x is equals to 225 upon 999. Okay, so we have successfully converted the recurring decimal into the fractional form. Okay, so do you see a pattern here? Yes. So when one digit was getting repeated, we got 9 as the denominator. When 2 digits are getting repeated, we got 99 as the denominator. When 3 digits are getting repeated, we got 999 as the denominator. Okay. So do you see a pattern here? I am sure that you are going to see this pattern definitely now. Okay, so the trick is very easy. You just have to count the number of digits that are repeating, okay, and just remove the decimal and divide the number by uh, the same number of digits of 9. Okay, okay, I think this is quite confusing. Let's discuss. So if the number is 225 bar, I'll remove the bar. How many digits are these? 3. So I will write 3 nines in the denominator. If my number is 0.63 bar, how many digits are getting repeating? 2. So I will write 63 with 2 nines in the denominator. Okay, easy. So this is a very easy way to convert a recurring decimal into fraction. Just remove the decimal, remove the bar, and divide the number by 9 or 99 or 999 or 4 times 9, depending on number of digits which are repeating. Okay, I hope this is clear to you. Okay, all right. So let us discuss this. Let us do this exercise. Okay, let us try to convert these recurring decimals into the fractional form. Simple, this number can be written as 0.37 bar. How many digits are getting repeated? 2. So what I'll do is that it would be 37 upon 99. 2 times 9. Okay. Here, what is this number? 0.456. 456 is getting repeated. Okay, so how many digits are getting repeated? 3. So I will write this number as 456 upon 999. Okay, pretty easy. Let's see this one. So this number is 0.9876. 4 digits are getting repeated, right? 9876, 9876, 9876. Okay, so I will write it as 9876. Remove the decimal 4 times 9. Okay, easy. So I hope this is clear. Okay, now let us solve a few more questions. Now, how do we convert such type of questions? Because the decimals that we have just done right now, the digits were getting, all the digits after the decimal were getting repeated. Okay, but if you look at this fraction, sorry, this decimal, then 2 is not getting repeated, but then 7979 is getting repeated. Okay, so how will we convert such type of numbers? Okay, so let's see that. So this number can be represented as 0.279 bar, because only 79 is getting repeated after 2. Alright, so please think, let's see how can we convert this. I'm giving you a minute. Please try to convert this into fractional form. Okay, all right, let's do this. So let us understand how will we convert such type of questions. Let us understand the trick first, the reason behind the trick. So first of all, we will take this number as let x is equals to 0.279 bar. Okay, so first of all, we have to remove this 2. So to remove this 2, I multiplied it by x, multiply it by 10. So it will be 10x is equals to 2.79 bar. Now this is changed into the form, the previous form. So now multiply this, let us take this as the first equation. Now we'll multiply it by 100 again. So we get 1000x is equals to 279.79 bar. Okay, so now let us take this as equation second. We'll subtract both the equations, equation 2 minus equation 1. From here I get 990x is equals to 279 minus 2. So I get 990x is equals to 277. So I get the number x is equals to 277 by 990. Okay, but in the exam we won't have this much time to do the conversion. We have to solve a lot of questions, and maybe this would be just a part of the question. Okay, so we have to know a trick. Okay, we will be short of time in the exam. So what we need to do in such type of recurring decimals is that you list the number, the digits after the decimal, which is 279. Then you subtract the digit which is not getting repeated, which is 2, and divide it by, now the number of nines would be equal to the number of digits which are getting repeated. So this would be 99, and we put a 0 for the number of digits which are not getting repeated. Okay, so please understand this. Okay, hi Harshvardhan, welcome to the class. Yes, I do. Okay, so let's come back to the question. So the trick is that we write the number of digits after the decimal point, then we subtract the number which is not getting repeated, and then we divide it by a number. Now for this number, for the denominator, you will write the number of the number of times the digit is getting repeated, and we will put 0 for the digits which are not getting repeated. Okay, so let us do this with this number also. Let us do it by this trick. The number of digits which are getting repeated. Let us do this. Getting repeated. How many? Just one, because this number is 0.83 bar. Only 3 is getting repeated again and again. Okay, and what is that digit? 3. Okay, number of digits which are not getting repeated. How many digits? Just one, which is 8. Okay, so how do I write it into fractional form? This number would be equal to, first of all, I'll write the number itself, 83. Then I subtract it from the digit which is not getting repeated, which is 8. And in the denominator, I'll write number of 9, the number of times the digits are getting repeated, 1 time. And then I'll write 0, the number of times digits are not getting repeated, 1 time. So this would be my fraction. So this would be equal to 83 minus 8 is equals to 75. So this would be equals to 75 upon 90. Okay. So I hope this trick is clear to you all. Please understand this. This would be really helpful in converting recurring decimals to fractional forms. I hope this is clear. Okay. Let's see. Okay. Now very important point here. There are few terms that are used in the question. Suppose if a question comes and it mentions that let x is a negative number, let x is a non-positive number. Okay, then what do we mean by these terms? Let's not get confused. Let us understand these terms properly. Okay, so positive numbers are the numbers which are greater than 0. Okay, numbers which are greater than 0. Okay, negative numbers are the numbers which are less than 0. Alright, non-positive. Non-positive numbers are the numbers which are not positive. Okay, it means the negative numbers and 0. Okay, so for this, negative numbers and 0. Okay, so numbers which are less than and equal to 0, non-positive. Similarly, what are non-negative numbers? The numbers which are positive or 0. Okay, so the numbers which are greater than equal to 0. Okay, 0 is neither negative nor positive. 0 is neither negative nor positive. Please remember this. Is 0 an even number? Yes, 0 is an even number. It is neither negative nor positive. I hope this is clear. These points are clear to you. Alright, okay. Now let us discuss a few points which would be very useful in questions further. Okay, let's see. So the first point is between any two real numbers, there are infinite number of rational numbers. Okay, so on this number line, if I have this number line and these are any two numbers, then between these two numbers a and b, we have infinite number of rational numbers and infinite number of irrational numbers. Okay, so please keep this in mind that there are infinite number of rational numbers and irrational numbers between any two real numbers on the line. Alright, okay. Numbers like pi and e are irrational. Okay, these are the non-terminating, non-recurring decimals. Okay, let's see. Other point is very important. Every prime number greater than 3 can be written in the form of 6m plus 1 or 6m minus 1, where m is an integer. Okay, so let us take any number, any prime number which is greater than 3. Let us list down the prime numbers starting from 2, 3, 5, 7, then 11, 13, 17, 19, and so on. So all these numbers, okay, can be written in the form of 6m plus 1 or 6m minus 1. If I take 5, this is 6 minus 1, 7, 6 plus 1, 11, 6 into 2 minus 1. Alright, so all the prime numbers can be written in the form of 6m plus 1 or 6m minus 1. So if you have to determine whether a particular number is a prime number or not, you can use this rule. Divide it by 6 and see if it is in the form of 6m plus 1 or 6m minus 1 or not. Alright, I hope this is clear. Next point. Number 1 is neither prime nor composite. Okay, 1 is neither prime nor composite. The only even prime number is 2. Okay, why? Because if the numbers greater than 2 would be even, it means that they would have more than 2 factors than 1 in itself, okay, which will violate the condition of a prime number. So the only even prime number is the number 2. Okay, now let us discuss this. Very important, you have to remember these points. The first point is total number of prime numbers between 1 and 50 is 15. So you can do this as an exercise, okay. Try to list all the prime numbers between 1 and 100 in the same manner as we did here, okay. So I did it till 20. You continue this list, okay, and try to list all the prime numbers between 1 and 100. So, but remember these numbers, okay. So the total number of prime numbers between 1 and 50 are 15. The total number of prime numbers between 50 and 100 are 10. So total number of prime numbers between 1 and 100 are 25. This would be useful while solving the questions. Okay. So it will be better if you can remember these points. You can make a note of these points. Next, when any two consecutive integers are taken and one of them is even, then their product is divisible by 2. Okay. If you take any two consecutive integers, then definitely one of them would be odd, one of them would be even. It means their product would be divisible by 2. Alright. Quite logical. Next statement, when any three consecutive integers are taken, okay, if I take three consecutive integers, a, b and c, okay, then definitely one of them, at least one of them would be even, one would be divisible by 3. Hence, their product would be divisible by 6. Why? Because if one number is even, it is divisible by 2. And one of these numbers would definitely be divisible by 3. Okay, it means their product would be divisible by 6. Okay, so this rule continues. If I take 4 consecutive integers, a, b, c, d, then I will have one even number. It means their product is divisible by 2. I'll have a multiple of 3, so it will be divisible by 3. I'll also have a multiple of 4, so it means it will be divisible by 2 into 3 into 4. Okay. So we can generalize this rule, and let's read what the rule is. Out of n consecutive integers, consecutive means back-to-back integers. If I write n consecutive integers, it means one of them would be divisible by n. Okay. So the rule is that the product of n consecutive integers is divisible by factorial n. Now what is factorial n? Factorial n is defined in this way. Or this is also the notation for factorial n and then this symbol, or you can define it with this exclamation mark. So this is like this. We multiply all the numbers from 1 to n minus 1, n minus 2 till the number 1. Okay, so all the numbers from 1 to n are multiplied, and that is how we get the factorial of n. Okay, so if you multiply n consecutive integers, then their product is always divisible by factorial n. Okay, so please take a note of this. Write down all these points. This will be very useful while you solve the questions. Okay, so the next class of number theory would be tomorrow at 11 a.m. Please do attend that class so that you can get more knowledge about number theory and you will be able to solve the questions properly. Okay, so in this lecture we have discussed the classification of numbers, the definition of types of numbers, and some important points related to numbers, and we have discussed how to convert a recurring decimal into a fraction. All right, so we'll be discussing more questions and more techniques on number theory in the next class, so please do attend that class. Thank you. Okay, so please don't forget to like, share and subscribe to this channel if you like this video, and if please do share the video with your friends and family. They can also get benefit from this. If somebody is preparing for CAT or any other management entrances, please share the channel. Okay, share this video so that they can also get benefited. Also, if you want to attend my special classes on Unacademy platform, please go to the Unacademy platform. You can get the plus subscription for the classes, or for special classes which are completely free of cost, you can attend those classes there also. Also, if you want to take the plus subscription of Unacademy, which you should definitely take if you're planning for CAT 21 or CAT 22 intake, then you can use my referral code, which is AAISH10, to get the instant 10% off over the entire fees. Okay, so hurry up, the batches are also starting. Don't miss the classes. Keep practicing. Thank you.